Okay, so rule number 4, please, you are going to using the bonded pair, and the bonded pair is just a straight line. Okay, and then number five, you distribute the remaining electrons around the atom. So you distribute, so you have to distribute the remaining electrons to the surrounding atoms. Okay, and then rule number 6. So the remaining electrons you have to give to those atoms which are surrounding the central atom. You give them. Okay, and then if so, the number 6. So if the electrons, if the electrons still remain, you give to the central atom. Still remain, then give to the central atom. The central atom. So even if you distribute, but you are still remaining with other electrons, you have to give to the central atom. You give to the central atom. Okay. There is going to be an exception. It means there will be an exception. One, we are saying there's a bonded pair represented by a straight line. It shows 2 electrons. So one line is just 2 electrons. We have got what we are calling as the lone pairs. The lone pairs are represented by the dots. Okay. Now, number 3, you have to calculate the total valence electron of a compound, meaning that in that particular compound, what is the total valence electron? How many electrons are in the outermost shell? Once you do that, you're going to connect now the central atom using the bonded pair. Number 5, you're going to distribute the remaining electrons to the surrounding atoms. Number 6, if the electrons still remain, you have to give to the central atom back, meaning that there's going to be an exception. There's going to be an exception to the octet rule. Now, anyone who's missed a point on the rules, we're going to draw an example, and then we'll counter check with the rules so that you appreciate more what we're saying here. Any rule that you might have missed here? Are we clear with the rules, all of us? Are we clear with the rules? Okay, so allow us, number 1, for the sake of understanding what we mean, we are going to draw the structure of what? H2O. Number 2, so allow me maybe to put also the rule number 7 for the sake of understanding. So form double bonds, or triple bond where possible. Triple bond where possible. So just take note of this rule. Where possible, you need to form the double bond where possible. So we'll draw these structures for the sake of understanding. Carbon dioxide, nitrogen dioxide, and then allow me to put, okay, but because I want us to follow through the rules so that you can appreciate more. Okay, let's start with the first 3. So please, we are using the rules, so you take note of what we're going to do when you're drawing the structures. So number one, they want us to draw the structure of water, the Lewis structure of water. So solution A, I want to draw the water. Okay. So first and foremost, remember, you have to calculate the total valence electron. So what's the valence electron of hydrogen? The valence electron of hydrogen. How many electrons does hydrogen have in the outermost shell?
1.
It has got 1. How many atoms of hydrogen do we have? We have got 2 atoms. Plus oxygen. What's the valence electron of oxygen? Oxygen. Are we comfortable with such a 6?
6.
It's a 6i. In case you're wondering where it's coming from, in short, the valence electrons go hand in hand with a group where we can find it. I can find oxygen in group number 6. Hydrogen is just in group number 1. Those are the valence electron in the periodic table. So if you don't mind, you can just check on the periodic table. Where can I find oxygen? It's in group number 6. Number 6, that's the valence electron. So what is our total electrons here? So to be 2 plus 6 will give us what? How many electrons? 8. So what you have calculated, this is the valence electrons. We have got only 8 valence electrons in water molecule. Now, the next thing we're going to do, I've written 82. No, this is the 8E. The E is electron. The E is just electron. Is it fine?
Yes, couldn't see that.
Is it okay?
Thank you. Yes.
Okay. Yeah. So there will be oxygen. I've got hydrogen. I've got hydrogen here. So rule number 3. What are we saying under rule number 3? Rule number.
Say calculate the total valence electrons of the compound.
Number 3, we connect the central atom electrons. So I have to say this is my how many electrons with? Are you still there?
We lost you, sir. I'm here.
Hello.
Oh, yes. So I'm saying out of 80, I have used 4 electrons. How many electrons are we remaining with?
4.
They're remaining with 4. So rule number 5, what is it saying? So we're remaining with 4.
Saying distribute the remaining electrons to the surrounding atoms. Hello.
I think the network for the site is terrible today.
You give to the what? Surrounding atom. So the surrounding atom is hydrogen here.
So you're breaking.
Screen and also to hear my voice. Hello.
Yes, sir.
Okay, sorry. I'll repeat a point. I was saying that rule number 5, we have to give the remaining electrons to the surrounding, but hydrogen has got an exception. You don't need to give it any electrons. So those 4 electrons that we are remaining with, you're going to give to the central atom under rule number 6. So those 4 we're going to give to the hydrogen here. So to the oxygen in the middle. So once you give to the oxygen in the middle, you have to check if you have 8 in total. So how many electrons do we have in the middle? So you have to check if it is balanced. You have to check for the octet rule. You check for the octet rule. Octet rule, it means we have to have 8 electrons at each particular point. So how many electrons are we able to see here in the middle? In the middle,
8.
we have got 2, 4, 5, 6, 7, 8. So you have to make sure that all of them, they are 8. Whenever you balance it, whenever you have to balance the structure. So you have to make sure that there are 8 always. You have to make sure there are 8 always. Okay, so basically what I'm saying, you have seen, so this is the structure, the Lewis structure of water. This is the Lewis structure of water here. Okay. Any question that maybe might have missed a point? We are going to do B together also. I'll do a number of the examples before you try one so that you get the concept.
Excuse me, sir.
Please proceed.
Why is I didn't get the point where you said hydrogen is an exception. Why is it an exception?
Yeah, hydrogen is an exception because it doesn't need any electrons for it to be stable. It doesn't need any electrons for it to be on its own. Is stable already. It's already stable. So those which are not stable, you need to give them electrons so that it has got 8 so that it becomes stable. So it doesn't need any. Okay, but not only hydrogen, there are some elements which has got which are stable as well. Most of those which have got exception, please take note, this exception rule, those elements, most of them, elements with odd number of electrons, of the valence electron, most of them, they've got exception. For example, what's the valence electron of hydrogen? We said it was 1. 1 is an odd number. So most of them, they have got an exception. Those which have got the odd number of valence electron. Yeah, is it fine?
Yes, sir. Thank you.
Let's check carbon dioxide together for the sake of understanding here. So let's do carbon dioxide together. So first and foremost, what's the valence electron of carbon? How many electrons does carbon have in the outermost shell? Please make sure you participate so that you don't miss any point. Carbon.
4.
It has got 4. That's good. I think oxygen we know now. We said oxygen has got 6. But how many atoms of oxygen do we have? We have got 2 of them. These are atoms. There are 2 atoms of oxygen there. So what is the total valence electron do we have here? So it will be 4 plus 6 times 2. Are we able to see 16 electrons?
20.
Not 16. Not 69. Yes. So please get me correctly. I'm going to draw a carbon. There's oxygen here. So remember, we're going to use the bonded pairs. So we're going to connect the central atom. So there will be 2, 4. The remaining carbon and the remaining electrons. So out of 16, I've used 4. So the remaining electrons you distribute around the atoms. So I've used 4. So it will be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I've given all of them around. So I've given all around. Now, once you've given them around, you check how many electrons do we have here in total. The first oxygen, how many electrons does it have in total?
6.
No.
8.
It's 8. That's good.
Yes.
The one in the middle, the carbon here, how many electrons does it have in the middle?
4.
It's 4. So it's 4, not balanced. Not balanced. It's not balanced here. Remember, in order for it to balance, it has to have what? It has to have 8. Let's check this oxygen. How many does it have?
8.
Oh, it has 8. It's balanced in short. So this one is balanced, and this one is balanced on the last, but the middle one is not balanced. So if it's not balanced, you have to use rule number 7. What does rule number 7 say? Where possible, you form the triple bond or the double bond, where possible. Because when you're forming the double bond and the triple bond, you want to balance it. So you have to use rule number 7. So we are going to balance this structure. It's not balanced, so you balance it. So how do you balance? You balance it by forming the double bond. So for example, this is a lone pair. So this lone pair, when you get a lone pair, it will form one line. Remember, this dot is just 2 electrons, which is equal to 1 line. So I can get also another lone pair here. It forms what? A lone pair there. So a lone pair, it will form what? A bonded pair. So I get one this side, I get one the other side. So you rub them. So if I rub these 2, I rub these 2. So let's check once more. How many electrons do we have here on this oxygen? How
8.
many electrons? is 8.
Eight.
In the middle, how many do we have now?
8.
Eight. Eight.
8 also. And then the last one, how many do we have also?
8.
Eight.
Is 8 also. So meaning that this is a structure of carbon dioxide. So the structure of carbon dioxide, we're saying it has got a double bond. It has got a double bond. It has got a double bond here. So this is how the structure, the Lewis structure of carbon dioxide will come out. Okay. Please allow me to put an emphasis. You have to make sure you have got 8 electrons at each and every point. You have to balance it always. Okay. The first one, I said hydrogen has got an exception. You don't need to balance hydrogen because it has got an exception. Okay. Is there no one who's missed a point the way we've drawn the structure of carbon dioxide before we draw the structure of the fed nitrogen dioxide? Please make sure you ask where you've missed a point so that you don't miss anything. Please, I will appreciate.
So how did you balance the carbon?
By getting the lone pairs. The lone pair is one line. So I got the lone pairs to make a bonded pair. This lone pair is as equal. This lone pair is as equal to one line. So I just got this so that it forms a bonded pair. Are you clear at that point?
Yes, sir.
Can we try see it together? Don't worry, we'll do a lot of the examples before you try one. Okay. Nitrogen dioxide. So again, let's check nitrogen. What's the valence electron of nitrogen?
5.
Nitrogen is 5. That's good. I believe oxygen, we know now. We said oxygen has got 2 atoms. So what will be the total in this particular case?
17.
17, eh? This is 17
Yes.
electrons. So what happens basically here, when I'm coming to draw, I'll draw the nitrogen, the oxygen here. So please, once more, maybe allow me to increase the font here. So I'm going to use, let me just increase the font for the sake of following through. So we're going to have 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So remember, I've got 16 and I'm remaining with how many electrons? 1. You give to the central atom, the 1 there. Okay. Now, the way we have given to the nitrogen, the 1 there, are you able to see that all of us, we have distributed all of them, 18, all of them? Is it okay? We have distributed 17, all of them, the electrons. So you
Yes.
check, are they 8 here? Do we have 8 electrons here? We have got
Yes.
8. Are we able to see 8?
Yes.
Do we have 8 here? No. In the middle, we don't have 8. So remember, I talked about the odd numbers. Remember, nitrogen has got what? 5.
5.
So in this particular case, we are not going to balance nitrogen because it has got 5. It has got an odd number. 5 is an odd number. So it means you don't need even to balance it. It's okay. You leave it the way it is. It's very much okay. Okay. You're going to see when you're going to do with this one. Do we have 8 on the last part?
Yes.
No.
8. So meaning that this is just the structure, the way it will remain. It means you are done here. Okay. Anyone who's missed a point under structure number C? I'll write 3 more examples also. Please, you can ask where I've missed a point just in case. Anyone who's missed a point there? We are going to draw the structure number D and E. We can go to D. Just confirm if we can go to D.
Yes.
So again, we check what's the valence electron of nitrogen? It's 5, right? Plus the valence electron of hydrogen.
1.
1, but we've got how many hydrogen atoms?
3.
We have got 3.
3.
So the total here will give us what? Will
8.
give us 8. So meaning that we have got nitrogen, I've got hydrogen, I've got hydrogen, and I've got also hydrogen here. So we're going to connect we're going to connect the central atom to the outside atoms using what? The bonded pair. So remember the bonded pair, this is a 2, 4, 6. I'm remaining with how many electrons? How many electrons are we remaining with?
2.
2. Those 2 electrons, I've explained about hydrogen. Hydrogen doesn't need any electrons. So those 2 electrons we're going to give to the central atom. These are the 2 central atoms. The electrons you give to the central atom. So when we give to the central atom, you check how many do we have in the middle here. What's the total in the middle?
8.
It's 8. So it means you are done. So it means you are done. This is the Lewis structure. This is ammonia. This is the Lewis structure of ammonia. So it means we are done here. Okay. Anyone else missed a point under the D before we go to the E? Please, like I mentioned, we'll do as many as possible the structures so that once you do your own, I'll give you a number of them. But I want you to follow through the rules here and there so that you don't miss any point, even as you try to draw the structures on your own. Is there anyone who's missed a point? Mr. Mtambo,